Good evening, everyone. If we are here, please let's all unmute and respond.
Good evening, ma.
Okay, thank you. I just want to be sure that.
Good evening, ma.
Good evening. I just want to be sure that you can. So let me share the material we'll be using for today's class. Today we'll be talking about, can we see the material I'm sharing?
Yes, ma'am.
Yes, ma'am.
So who can read the title of the topic who can tell us the title for today's topic? Anybody want to tell us the title for the topic of today? Nobody.
Hormones acting through calcium and phosphorinocytides, the modulation calcium system.
Inositides. Yes, somebody was reading for us. Sorry, for that interruption. Yes, who wants to read today's topic for us, please?
Okay. Hormones acting through calcium and phosphorinocytides, the modulation calcium system.
Thank you, sir. Yes, just exactly as we had. That is our topic for today, the calcium calmodulin system. Has anybody ever, I'm sure we've heard about calcium before, but the calmodulin is what I'm not sure about and how this calcium is modulated. So if you remember last class, we talked about secondary messengers. And just to bring to your notice, the poll is already up. Please make sure you fill in your details. Then at the end of this class, we'll be having a short quiz. You determine whether you break into groups or you do it individually. By the end of this class, we'll definitely have a short quiz and you'll submit before our Zoom time expires. So please inform your other colleagues. Yes, so back to our lecture. We talked about secondary messengers last week, and we are continuing today. So calcium is also a second messenger. And remember, we said hormones were the first messengers. Do we remember when we sent our answers to the group chat? A bit to the Zoom chat. So we said cyclic EMP was a second messenger. In addition to the second messengers we listed last week, calcium is also a second messenger, and it is the most versatile second messenger in cell signaling. Calcium can be gotten from an external source or from intracellularly or extracellularly, which is why it is important to eat a balanced meal, because If the body needs calcium, the body is always in need of calcium because it uses it as a second messenger. Now, if the body needs calcium and it is not uh, available or present within the diet, the body will get it from the bones, which is why we have osteoporosis. Have we heard of osteoporosis before? I want each person to tell me what osteoporosis is in the Zoom chat. Just two in one question. What is osteoporosis and in what type of people is it common? What is osteoporosis? In what people is it common? So I'll give us just 2 minutes for that before we continue. Send it to the Zoom chat, please, not the WhatsApp chat, the Zoom chat. What is osteoporosis? In what type of people is it found? Or is it commonly found? So we just have 1 more minute for that exercise. It's just a simple exercise. Only one person. Let's answer. Weak bones, old people, male, female. What do you mean by weak bones? Ogunyemi just said weak bones. And it's found in old people. Now, what do you mean by weak bones? How does the bone become weak? What weakens the bones? So we just have a few more minutes, a few more seconds. I've also post I'll also share the YouTube link. So please share so that others can have access to the class, to the recording of the class. Okay, so our time is up. Now, yes, we are all correct. All of you that said weak bones. Osteoporosis is the weakening of the bones. And how does this happen? I told you that we said number one, calcium is the most versatile second messenger. Two, it could be intracellularly or extracellularly. And I said if calcium is not present within your diet and the body needs calcium, how does it get it? Through the bones. So the bones will be depleted gradually. That's where the weakness comes from. So it is important. As youths, don't abuse your usefulness. A lot of you say, I'm busy, I cannot cook. If you cook, please eat good meals. Don't just be taking donut and Fanta 3 times a day, 7 days a week. You are doing your body damage. You are doing damage to your body. So always remember, garbage in, garbage out. What you give your body is what your body makes use of and gives back to you. So we continue now. How is calcium released? Through the phosphorinositide pathway. And this pathway uses GQ coupled receptors. Okay. So in a step-by-step mechanism, the first thing that happens is that the required hormone binds to the receptor, that is the GQ coupled receptor. And once the hormone binds to its receptor, GQ activates PLC beta. And the key players in this activation is the GTP. GTP is an energy currency. It's like a lower form of ATP. So the key player in this activation is the GTP bound G alpha Q submit. And once this PLC beta has been activated, PLC beta now hydrolyzes phosphorinositide phosphate 2. Using phospholipase C beta. And when this happens, it now leads to generation of 2-second messengers. That's inositol phosphate and diacylglycerol. I hope you notice that I'm adding some things that are not in the note. So please, it's good for you to pay care attention. Okay, DAG is diacylglycerol. Once these 2-second messengers are generated, IP releases calcium ion from the endoplasmic reticulum, and DAG activates PKC, that's protein kinase C, at the plasma membrane. So this is a six-step mechanism of how calcium is released. And it is only released if it is needed by the body. Phosphoinositol phosphates. This is in a one-line equation of how it happens. IP diffuses through the cytosol, binds through IP3R on the ER, and releases calcium into the cytosol. Then DAG remains in the membrane, activates PKC, which requires calcium as a cofactor. I hope you understand. If you don't understand, please raise up your electronic hand. Know how well we are communicating. Okay, in the absence of any electronic hand. Okay, Iyoluwa. Iyoluwa, please unmute and let us know what aspects you do not get. You're mute. Are you there? Is Iyoluwa still there?
Hello, ma. Can you hear me? I'm
Yes, I can
sorry.
hear you.
I'm currently on the road. That's fine. I do not want that to disrupt the class. My question is around how calcium is gotten from the body. You were trying to explain that, but I was struggling to hear the things you said.
Yes, I said the sources of calcium could be intracellular or extracellular. Intracellularly, when we take our diets, that's extracellularly. When we eat, you eat bones, you take supplements. Majorly, calcium is gotten from bones. That is how it's gotten extracellularly from the diet. Now, intracellularly, it is gotten by eroding the bones. Because if the calcium storage in the body is not sufficient and the body needs calcium, because calcium acts as a cofactor with so many enzymes. It is the most versatile and the most used second messenger. So when the body requires calcium and it doesn't get it from your diet, it erodes the bones. That's why you have osteoporosis in old people. When you are young, you might not quickly notice it. But by the time you are getting older, if it has been happening over the years, in fact, it's so bad in some people, the bone will just break. Their leg will just break, or their hand, any part, because over the years, calcium has been eroding, you know what erode means? Chipping off. The bones have been chipping off little by little because of poor diet, poor intake of calcium. So that is how calcium is got from within the body if it's not in sufficient amount in storage. Is that okay?
Very well, ma. Thank you, ma.
Okay. So we'll now continue. Yes, so we were saying how calcium is released. When calcium is needed, how it is released through the it can be released through the PIP cascade pathway, which I've simplified for you in 6 steps. Now, okay, so, and this is in a one-line equation of how it is released. PIP is activated to PLC beta. PLC beta releases IP and DAG. And this IP now diffuses through the cytosol, binds to IP3R, and on the ER, releases calcium into the cytosol. I'm just summarizing. I had a question. Yes, I knew I had a question before Yoluwa asked. Sorry, Yola. Now, my question is, what is a cofactor? We said calcium acts as a cofactor. In the Zoom chat, I'll just give us 1 minute for this exercise. Let me know what you think a cofactor is in the Zoom chat. Please note that my attendance is in various formats. In addition to the poll, our chat box is another way we could take attendance. So please, once there is an interaction or an activity, a class activity, please be part of it, because it's also a means of taking attendance in the course of the lecture, because of some of us that just like to log in and be absent. You'll just be logged in but be absent. So please, we have just 1 minute to tell us what a cofactor is. Let me see what answers we have here. It's a non-protein substance or metallic ion. Next, non-protein substance, no metallic ion required by an enzyme. Okay, let's see more people. If anybody has anything different. Bajoye says a cofactor is a non-protein substance required by an enzyme. Okonkwo says a cofactor helps enzymes speed up chemical reactions in the body. Non-protein substance. Okay, so our time is up. Thank you. So yes, I just needed us to understand how calcium acts as a cofactor. Now, calcium has to attach itself to an enzyme. That's a cofactor. A cofactor is a metallic non-protein substance that works with enzymes. And we know it's metallic because it has a charge. You can see Ca2 plus. So let me take for example a car. Let's say for example, the car is the enzyme. You know, without petrol in the car cannot work. Do we agree? Yes.
Yes.
Also, if there's no water in the car will not function well. It might work, but after sometimes it will start to give you some signs. It will not work to its optimum, what will I say, capacity, yes. So cofactors are those little things, if you call it, say, in a layman's language, that boost the work of an enzyme. So that's what calcium does. So when calcium is released, it attaches itself to the enzyme it works with, and then the enzyme goes and elucidates the effects required by the body. Now, how we say sources and regulation of calcium. Two sources of calcium, we have the cytosolic calcium, that is the intracellular. Okay, so it's found in the endoplasmic reticulum, and like we saw in the sixth step, it is released through the IP receptors, which is triggered by a hormone. Now, the extracellular source is through our diet or voltage-gated channels. What do we mean by voltage-gated? What does voltage-gated mean? Please, you answer in the Zoom chat. Let's see. What does voltage-gated mean? Voltage-gated. I've told us as much as possible, please make sure you participate in class activity. So that it's a way of making sure. Okay. So there are also protein channels whereby calcium, that pass calcium. Okay. Now, when enough calcium has been released, how is the reaction stopped? The reaction is stopped via the SERCA pumps. The SERCA pumps are calcium channels. They are channels that pump calcium back into the ER. And these pumps use a lot of ATP. Because calcium must not be left in circulation. When there is too much calcium in the body, when there is excess calcium in the body and is not mopped up, that's when you have kidney stones. Have you heard of kidney stones before? Kidney stones is the sedimentation of calcium in any part of the body. And in men, it could be severe, because if these calcium particles become sedimented, take for example, in their urine passage, some men will be finding it difficult to pass urine, or they'll be passing urine with a lot of excruciating pain. So when calcium has finished working, when enough calcium has been released, it must be mopped up and the reaction must be stopped so that it doesn't cause havoc to the body. And this is done through the SERCA pumps, the calcium channel. Also the PM, plasma membrane calcium ATPase channel, is also used to export calcium out of the body. We also have the sodium calcium exchanger. It's a secondary active transport. And then we have the calbidin parvalbumin, which is from the name, you should know, from albumin, from the name, it's a calcium binding protein that also mops calcium out of the system. So we have 4 different pathways via which calcium is mopped up. That will show you how much excess calcium must not be left within circulation, because it will do more harm than good. Now, the next thing we'll be talking about is the calcium calmodulin system. Okay, the calcium calmodulin system is a calcium sensor. It is made up of 148 amino acid, and it is highly conserved across eukaryotes. Give me an example of eukaryotes. Are they multicellular or unicellular? Eukaryotic organisms. In the Zoom chat, eukaryotic organisms, are they multicellular or unicellular? There are no fast, we don't have fast fingers. Oh, thank you. Iola is yes. They are multicellular, thank you, like human beings. So the modeling calcium system are universal calcium sensors. They contain 4 helix loop calcium binding domains, and they have no enzyme activity of their own because they are a regulatory subunit. So how does this calcium calmodulin binding system work? They work by collapsing free calcium. Free calcium in the blood binds to calcium calmodulin complex. When this happens, when this complex is formed, calcium calmodulin complex collapses, and then this collapse exposes the hydrophobic parts of the complex. When the calcium calmodulin complex collapses, it exposes the hydrophobic parts, and then it traps, and thereby trapping the calcium. So it helps to mop up free calcium or loose calcium in the blood circulation, thereby binding calcium to one of its hands and increases affinity for others. Okay, so we said it has 4 EF hands, which means it can bind 4 calcium. So the calcium calmodulin helps to trap calcium and mop it out of the bloodstream. Now, the calcium calmodulin target proteins, that's the one we spoke about. How does it work? We have how many types? 3 types. You have CKMKI1, 2, and 4. The 2 is most abundant in neurons and the memory and learning part of the brain. And the CAMKI1 phosphorylates transcription factor PrEP. You need to read. If I digress, we will lose the point. But the transcription factor are seen in protein synthesis. If a new enzyme is to be formed, if a new protein, we say all proteins, all enzymes are proteins. So if a new protein is to be synthesized, that's when you have transcription factors. The DNA first unwinds, then the DNA is transcribed to RNA. Okay, so it is at this point that you have CAMKI1 needed, because remember we said calcium works as what? A cofactor to an enzyme. So the function of this CAMKI1 is to phosphorylate transcription factors like PrEP, and its action is regulated when CAM plus CAM KK is needed for full activation. Please, if you are not getting what I'm saying, please just raise up your electronic hand. I will recap. We are talking about regulation of calcium, how it is mopped out of the bloodstream. Okay, so for the calmodulin dependent protein kinase, the CAMP-K2 is composed of 12 subunits, is calcium dependent, and on the molecular basis, it stays longest in the hippocampus. Hippocampus is what part of the body? Is it the brain? Hippocampus is seen in what part of the body? Let's see if we still remember some biology. What part of the body is the hippocampus? Abi, is he on campus in Unilag? Nobody knows. So I get my own mark. I give myself mark for answering this question. Thank you. Yes, thank you. So hippocampus is seen in the brain. So this CAMP-K2 is found majorly in the brain. Then there are other critical calcium calmodulin targets. They also work on the smooth muscles and the type of calcium CAMP that works on the smooth muscles is known as the MLCK, that's myosin light chain kinase. And is used by clinicians to treat hypertension because that's what the drugs target. You know, hypertension, the blood pressure is high. The blood pressure is high, so they help to, the hypertensive drug helps to relax the muscles. When you give somebody an hypertensive drug, the person will now become very sluggish and slow. So it helps to relax the smooth muscles and prevents them, instead of contracting, they become relaxed. Now, we have also the adenylyl cyclase target opposes GI signaling. And once this happens, there is increase of cyclic AMP production. Let me just take one more. You have the nitric oxide synthase. And it is clinically used for vasodilation and neurotransmission in cases where maybe the patient is having issues with neurons, with transmission of nerve impulses. So that is used for the treatment of poor coordination of nerve impulses. Now, we want to discuss how calcium and CAMP are related or are intertwined. Now, calcium calmodulin activates ACI1 and ACI3 and AC8. And once this happens, cyclic AMP is increased. Remember, cyclic AMP is also a second messenger. But if calcium calmodulin complex activates PDE1, this ACI1 is part of the things we did last class. What is ACI? AC, by the way. What's AC? Because once you don't know something, it will interfere with the understanding. Please, if just in case I cannot for those people in the waiting room, you can join through please let them join through the YouTube link, because I get carried away with the lecture, so that they don't just keep on waiting in the waiting room. Once the lectures have started, I might not be able to be going to, that's why I send the YouTube link. Those in the waiting room, let them join from the YouTube link, so that they don't have to be waiting for me to let them in. Please let them know. Send a message that those in the waiting room should join, to go from the YouTube link. And whenever I ask a question, they should also they should be a part of the class. They should also send their own answers to the chat box on the YouTube. Okay, I asked the question. Let me see our response. Okay, then let's cyclist. Thank you. So that we'll be on the same page. So we say when calcium calmodulin complex activates AC1 and AC3, cyclic AMP is increased. And when calcium calmodulin complex activates PDE instead, CAMP is reduced. Okay, so that is how calcium calmodulin complex is related to cyclic AMP. Now, see calcium and PKC. That is where we started from. DAG, that's diacylglycerol and calcium, together activate PKC. And PKC has 4 subunits. Okay, so for the novel PKC with this subunit that is in brackets, it needs only DAG to activate it. And for the other type of PKCs that is in bracket, the lambda PKC, it doesn't need any second messenger to activate it. Okay, now these are some examples. We said hormones. When hormone, the release of the hormone on the receptor is what triggers the reaction to start. So this is the hormone epinephrine. Epinephrine is released, it binds to its receptor. And when that happens, GQ, what's GQ? G protein Q activates PLC beta, and activation of PLC beta allows for the release of IP3 or DAG. And what is the effect? The smooth muscles contract. Vasopressin is another type of hormone. When vasopressin binds to its receptor V1, also in series of reactions, IP3 and DAG are released. What is the effect? Vascular smooth muscle contraction. Now, this third hormone, CRH. When it happens, it activates and releases DAG, and the effect is the TSH release from the throat drops. So we have the list endless. You have oxytocin, you have gastrin, you have angiostensin. each of these hormone is specific, even though they are releasing the same. Please note, even though these hormones, this table, the significance of the table is trying to tell us that even though different types of hormones from different parts of the body are releasing the same product, IP3 or DAG. But please take note that they are elucidating different physiological effects. That is, the same product does not mean that it will be the same effect. The effect will depend on the hormone that triggered the reaction. Are we together? So if it was oxytocin that triggered the release of DAG to release calcium, then it will be for uterine contraction. Even though different hormones are giving us the same product, but depending on the hormone that triggered the release of that product will determine the physiological effect. Did we get that, please?
Yes, ma'am.
Okay, thank you. So we'll continue. Now, what are the clinical relevance of what we've been saying about calcium as a second messenger? Calcium must not be left in the blood circulation. Calcium this, calcium that. What is the clinical relevance? Clinically, it is used to treat disease condition, especially the pharmacists in the pharmacological departments. So some drugs, depending on the state of the individual, of the patient, the condition might be, if the condition is phenylephrine is a medical condition where the person is having trouble with is having trouble digesting this amino acid. So what does the clinician do? The drugs that is given is a drug that targets alpha-1 AR and is a drug that is an agonist of alpha-1 AR, and it works by activating calcium CAM-LCK pathway. Which amino acid? I'm trying to recall the amino acid that is related to, is it phenylalanine? Okay, yes, phenylalanine is an amino acid. So what happens is that some people, they are deficient in some enzymes. So they cannot metabolize. Let me give an example. Some people, when some people take milk, they'll become bloated, very uncomfortable. They'll have a lot of flatulence. That's because they don't have enough enzymes to break down the milk, or they don't have the enzymes at all. So that's why some people will eat some type of food and be having serious trouble with it. While some others, in fact, that would be their best food. They say one man's meat is another man's poison. That's what the Englishman says. So it's always good for you to know your body type. So for a condition, so for different medical condition, these are the drugs. And what this table is just showing us how this drug works to aid relief of every disease condition. Now, for this prazosin is a drug that is used to treat what? From the mechanism, let's see if we can know prostrate, signaling in prostrate. So prazosin, what do you think prazosin is used to treat? From the mechanism, is used to treat erectile dysfunction. Now, this ryanodine, what is it used to treat? But the most important part is the mechanism, is the biochemistry part of it, which I just explained to us that depending on the disease condition, the drug works as either a channel, an antagonist, or an inhibitor to bring relief or solution to the situation. So as a recap, what we've been saying since morning about calcium as a second messenger, its release is that when calcium is needed, the hormone in question, any hormone, either epinephrine, norepinephrine, the hormone binds to its receptor, and an hormone binds to its receptor. When this happens, G protein is activated, and in a series of reaction, G protein activates PLC beta. PLC beta breaks into IP3 and DAG. DAG releases IP3R from the ERM, binds to its receptor on the ER. IP3 binds to its receptor, IP3R on the receptor. DAG goes to release PKC from the membrane, and in each of the reaction channel, IP3 releases calcium, while DAG releases PKC from the membrane. And depending on the need of the body, please note that in capital letter, bold capital letter, depending on the need of the body, calcium binds to the calcium calmodulin complex. When it has finished its work, is either calcium binds to an enzyme as a cofactor, depending on the need of the body. If it needs to bind to an enzyme, it will bind to the enzyme it works with and work as a cofactor. And when it has finished its function, it's now through the calcium calmodulin complex, calcium is removed from the system, or it works in muscle contraction, gene expression, or T cell activation. T cell is an example of an immunoglobulin. You know immunoglobulin. Immunoglobulin are like the police of the body. They help in defense mechanism. They help to fight the body to fight antigens. Any questions so far before I ask you my question? Any questions so far? So these are key takeaways. PIP is the membrane precursor. IP releases calcium from ER. Calmodulin has 4 hands and undergoes conformational changes to bind calcium. Please, people in the waiting room, let them join from the YouTube link, because it's a lot of distraction for me to be okay. So please let them join from the YouTube link. Now, this is what I was saying at the beginning of the class. These self-assessment questions, do we want to do it? Now, I want us, okay, because of the people in the YouTube link, because we might have people in the YouTube link, each of you will answer these questions. I'll just give you 20 minutes. In the next 20 minutes, this will be quiz 1. You answer it. Take a screenshot of your answer and send it to the chat box, either Zoom or how many questions are there? Just write the answers. You don't need to repeat. I'm going to reduce the font so that you can see it. You can see it. Let me reduce the font. You can see it at one peak. Is this too small? Are we together?
Yes, ma'am.
I don't want to be scrolling. I just need you to take a screenshot of it. Let me see if I move to the next page. If it's on one page, can we see it at once so that I don't have to be scrolling up and down? Wow. It's not still fitting into one. You know what I'll do? This one down, I'll bring it up. Short answer. We have 5 OBJ and then 2 short answer questions. So I'll just create a table and make it 2-column table. So you answer it individually and send a screenshot. Wow. Can you send a screenshot of your answer to the Zoom chat? Is it possible to send a screenshot of your answers to the Zoom chat? Okay, just send your answers to the Zoom chat. No need to screenshot it. We need to insert table. Can we see it at a glance? The ones that are not showing. Hello, class. Are we still here? Please, no, this will be our first quiz. Oh, I'm going to record this in particular. So just write your answers, number 1, A, number 2. Send it to the Zoom chat. No need to copy the questions. No need to rewrite the questions. We have only, let me give us just 15 minutes because I trust you. I trust a lot of you. 15 minutes, guys, too long. I'll give us 5 minutes.
Give us 5 minutes. We can't see question 5.
You can't see question 5. Okay, I don't want to scroll. Please, I'm still trying to set it. Because if I scroll, somebody in question 1 will not see question 1. So please just be patient. Be answering the ones you can see while I try to make it into just one sheet. Okay. Yes, I want it to be on one page. So everybody can see all the questions at once now. So I'll just give us 5 minutes. I'll just give us 5 minutes. Please send your questions to either the Zoom. If you are not on Zoom, please join from YouTube. If you are not on Zoom, join from YouTube. Send your questions to the chat box. I'll get your questions from there. I'll just give us 5 minutes. So by 8:09, I'll stop. Nobody is answering yet. Nobody is sending anything to the chat box. Let me see. And those of you that are always waiting for somebody to first send, please be careful. Because at exactly 8:09, I will end this class. I will end at exactly 8:09, we will end this class. Okay, I've given you some more, only 24 people here. Let me even check people on YouTube. Only 24 people out of 39 have responded. Let's see how many responded on YouTube. We'll have to end the class now because the time is fast spent. Let's see how many people. Please take notes. It's important we respond to the questions. How many people here? Because it will be graded. So if you got locked out of, please inform the class. That's why we have 2 links. If you got locked out of the Zoom link, please join on YouTube. Or if I'm not letting you in, those of you in the waiting room, please go and join on YouTube. Once the class has started, it causes distraction. It distracts the class, having to let people in. So please, if you're in the waiting room, if you got locked out, join on YouTube. I'm just giving us time of grace. We are in our time of grace now. For those of us that have poor connection. Please don't submit one answer twice. So please don't submit. You submit one answer twice, you've disqualified yourself. We're in time of grace now for people that are complaining of poor internet connection. We're in time of grace now. I'll just give you 2 more minutes for the people that have weak connections. Please tell your colleagues, those of them that got locked out, some of them are saying they got locked out. Those of you in the waiting room, those of you that are locked out, please join on YouTube. I can still see people in the waiting room. Please let them know. If you're in the waiting room, go and join through the YouTube. Once the class has started, I will not let anybody in again from YouTube. Or you can see everything we are doing from the YouTube link. So 1 more minute left from our time of grace. This is majorly for people that had weak or disrupted internet connection. Okay. So this how far we'll go for today. Next class will continue. Let's all unmute and share the grace. May the grace
of the Lord Jesus Christ, the love of God,
love of
fellowship of the
God
Holy Spirit, be with us
be
now and forevermore.
Forever, amen.
all
Surely,
believe.
Bless and mercy shall follow us all the days of our life. I wish I did it
shall
now.
do days of our life. I wish I do in the house of the Lord forever and ever. Amen.
Before we leave, I learned that Dr. Balawa is through with her part of the other course 322. So we'll also be having, I'll start my part with you on Friday. I've sent a message to you through your course rep. So see you on Friday for 322. What's the title? That's the code. What's the title of the course? Do we remember?
Amino acid and protein.
Okay, thank you. So we'll meet on Friday.